In order to solve our probability problem, we need to understand some background theory about the topic. When probabilities are joined by and, it means intersection. Therefore, we multiply by probabilities. When probabilities are joined by or, it means union. Therefore, we add the probabilities. When having or in an independent event, the probability of both events occurring at the same time must be subtracted from the equation. To avoid duplicating the probability, this is not necessary in mutually exclusive events probability. Finally, conditional probability means the probability of A given B, or the probability of B given A.
For problem 1, section A, we are given the probability of a person choosing strawberry ice cream and the probability of a person choosing strawberry ice cream and vanilla ice cream. We need to find the probability of a person picking vanilla ice cream.
So, for problem 1, section A, we are asked to find the probability of A. We are giving the probability of B and the intersection of A with B. Knowing that the intersection of these two probabilities is the multiplication of both, we must divide to find the probability of A. So, we divide 3 over 80, which is intersection of both probabilities, by 1 over 20, which is the probability of B. As a result, we get 3 over 4 as the probability of A.
For problem number 1, section B, we are giving the probability of a person choosing a burger and the probability of a person choosing fries. We're asked to find the probability of a person picking both.
For section B, we were given the probability of A and the probability of B. We were asked to find the intersection of A with B. To do this, we must multiply both probabilities. Therefore, we multiply 3 over 8, which is the probability of A, by 23 over 30, which is the probability of B. As a result, we obtain 23 over 80, or 0.2875, as the intersection of A with B.
For problem 1, section C, we are given the probability of a person being Australian, a person being Canadian given he's Australian. Therefore, we need to find the probability of a person being Canadian.
For section C, we are given the probability of B given A and the probability of A. To solve this, we must solve for x using the formula we know for conditional probability. We know the probability of A is 5 over 6, and the probability of B given A is 3 over 4. Therefore, 5 over 6 multiplied by x, all divided by 5 over 6, will equal the probability of B. We solved for x. Now, 5 over 6 times x equals 3 over 4 times 5 over 6. Then x equals 3 over 4 times 5 over 6 divided by 5 over 6. As a result, we get 3 over 4 as the probability of B.
For problem 1, section D, we have the probability of a person owning a dog and the probability of a person owning a cat. We want to find the probability of a person owning a cat given he owns a dog.
For section D, we must find the probability of B given A. We know the probability of A is 13 over 20 and the probability of B is 7 over 10. Therefore, using the formula for conditional probability, we must multiply 13 over 20 times 7 over 10 and then divide by the total 13 over 20. As a result, we get 7 over 10 as the probability of B given A.
For problem 1, section E, we're giving the probability of a person traveling to Paris and the probability of a person traveling to New York. We must find the probability of a person traveling to Paris or New York.
For section E, we must find the union between the probability of A and the probability of B. To do this, we will add both probabilities and then subtract the intersection of both. We add 7 over 10, which is the probability of A, and 1/2, which is the probability of B, and we get 6 over 5. Now, we must subtract the intersection. To get the intersection, we multiply both probabilities, which is 7 over 20. Therefore, we get 6 over 5, take away 7 over 20, and end up with 17 over 20 as the union of these probabilities. This 17 over 20 may also be represented as 85%.
For problem 1, section F, we're given the probability of a person dancing and a person singing given he or she dances. Therefore, we must find the probability of a person singing.
For section F, we must find the probability of A. We have the probability of B, which is 9 over 20, and the probability of A given the B, which is 7 over 20. Knowing this, we use a conditional probability formula and solve for x. We do 9 over 20 times x and divide it by 9 over 20 equals 7 over 20. Then 9 over 20 times x equals 63 over 400. Then x equals 63 over 400 divided by 9 over 20. So x equals 7 over 20. As a result, we get the probability of A is 7 over 20.
In order to solve our z-score problem, we need to understand some background theory about the topic. First of all, when asked to contract a confidence interval, we must determine if it is a t-test or a z-score. That is needed. If we are given the standard deviation of my population, then we use the z-score. A confidence interval will be provided a range of values that may contain the parameter. It is useful to predict how the rest of the sample will act. Central limit theorem explains that the mean of your sample equals the mean of your population. And we have our formula here that we will be using to construct the confidence interval.
First of all, it is noticed that this is a formula we're going to be using for this problem. Before we plug in all of our values in our formula, it is easier if we write down all of our values we're going to be needed. We're going to be needing our sample size, our mean, our z-score, our sigma, and our confidence level in order to plug everything in the formula. In case we don't easily have our z-score of our confidence level to plug in the formula, we can easily find it by locating it in the table, inside the table, and then finding the coordinates and putting together the number. In this case, it's 1.645. Now that we have all of our information together in an orderly manner, we're going to plug in the formula. First, the mean, which is 2.4, minus our z-score, which is 1.645. Then we open a parenthesis with our 1.2, which is our sigma, over square root of 43, which is our n, our sample size. We double close parentheses, and then we write the exact same thing, but we're going to be adding 2.4 plus our z-score, which is 1.645, open parentheses, 1.2, which is our standard deviation, over square root of 43. We're going to put all of that information in the calculator, and it's going to give us 2.099, which is smaller than the mean, which is smaller than 2.701. We don't really know the exact value of the population mean. However, we can assume that we are 90% sure that the population mean is between this range.